Hello everyone, let's look at some numericals based on optical instruments. Example 1 says, calculate the magnifying power of a magnifying glass of focal length 5 cm with image seen at the least distance of distinct vision. We learned in theory class that a magnifying glass basically means a simple microscope where we had two forms for magnification. One, when the image is formed at D, and that is given as 1 plus D by F. Another form would be M infinite is equal to D by F. This is the magnification when the final image is formed at the least distance of distinct vision, and this is the expression for magnifying power when image is formed at infinity. Here the question says to calculate the magnifying power when the image is formed at least distance of distinct vision. So we know that in theory class we studied D is equal to 25 centimeter. Therefore, putting it here, the magnification when the image is formed at least distance of distinct vision is given as 1 plus D would be 25, F is 5. And keep in mind that in this case both D and F is in centimeter, so in this expression that gets cancelled, so it becomes 1 plus 5 is equal to 6. Example 2 says a microscope consists of two convex lenses of focal length 2 cm and 5 cm placed 20 cm apart. Where must the object be placed so that the final virtual image is at a distance of 25 cm from the eye? Now this is basically a compound microscope, and we have learnt in theory classes that a compound microscope consists of two convex lenses called as objective and eyepiece. We learned that the focal length of eyepiece is greater, therefore here this 2 cm would be the focal length of the objective, which is 2 cm, and focal length of eyepiece is equal to 5 cm. And the distance between them, if you recall the expression, we had two lenses like this. This distance between them was called as length of the tube. Suppose somewhere here, if an object was placed, this distance is called as u0. Let this be AB. The image of this is found somewhere here. We call it as A dash, B dash. The distance from the optic center of the objective to this point would be V0. This would be V0. And the final image is formed somewhere here, like this. We called it as A double dash, B double dash. The distance from here to here was given as UE because the image formed because of the objective acts like a virtual object for the eyepiece, and this distance is called as VE. You can go back and look at the expression derived in the theory classes. Now the length of this tube, which is called as L, would be this distance, that will be V0 plus UE. It is just the length, so we just put its magnitude. Now here the length of the tube is given as 20 centimeter, and the image is formed at D, so therefore V is equal to minus 25 centimeter by sign convention. So this is the data given. So from here we need to find what is u0. So question says to find what is u0. Now to find u0, we can use the length equation, which says 1 by f naught is equal to 1 by v naught minus 1 by u naught. We know what is f naught as given here. We don't know what is v naught. So first thing is to find what is v naught. To find v naught, we can use what is form for L. So we find v naught using L, but in L we should know what is UE. So to find UE, we use what is VE. So we first find what is UE. That's the first step. Find what is UE, and from this UE we find what is L, and from there we find what is U0. So that's what we required. So we'll do it step by step. The first thing is we'll find what is UE. So using length equation, 1 by FE is equal to 1 by VE minus 1 by UE. Now from here we should find what is UE, but by sign convention both VE and UE are negative because the light is from the object is going from left to right, but to find UE or VE are going from right to left, so both are negative. Then this equation becomes 1 by FE is minus 1 by VE plus 1 by UE. So from here 1 by UE is equal to 1 by FE plus 1 by VE. It is equal to 1 by FE. FE is given as 5 centimeter. So it becomes 1 by 5 plus 1 by 25. We already put the sign convention for VE here. Again, don't put it here. This is equal to 25 plus 5 by 5 into 25. That will be 30 by 5 into 25. So 5 ones are 5 6 are. Therefore UE is equal to 25 by 6. Since here both UE and VE is in centimeter, this also would be in centimeter only. So this is what is UE. Now we know what is UE. Let's find what is, from the expression for L, let's find what is V0. Recall that L is equal to V0 plus UE. The L value is given as 20 centimeter. So 20 is equal to V0 as it is plus UE would be 25 by 6. From here we get V0 is equal to 20 minus 25 by 6. That will be 120 minus 25 by 6. That will be 95 by 6 centimeter. So we found out what is V0 also. Next thing is to find what is U0. So what you can do from here is, we know 1 by F0 is equal to 1 by V0 minus 1 by U0. For the object term, V0 is positive and U0 is negative. With that in mind, what you get from here is 1 by F0 is 1 by V0, it's 1 by U0. Or you can just do directly also here. We'll bring 1 by U0 this side, the same meaning. It's equal to 1 by V0 minus 1 by f naught is equal to 1 by v naught. V naught was 95 by 6, so this becomes 6 by 95 minus 1 by 2, because the focal length of objective was 2 centimeter. That is equal to, it will be 12 minus 95 by 190, that's 1 by u naught. U naught is equal to 190 by minus B83 is equal to minus of 2.29 centimeter. Now here observe the answer is negative because I haven't put the sign here. I just took this to this side. In case if I put the sign here also, the sign here, then it would have been like this. Bring it here, it would have been minus sign here. So the point is, in such cases, be careful with the answer and try to interpret the answer carefully, and also be careful with sign conventions. So in case we put plus sign here, we got this as positive only. So don't think that since u is positive, it is somewhere else. The idea here is u be positive if you put convention here only. So be careful with such notations. So practice more numericals, it becomes clear from there. The magnification produced by an astronomical telescope for normal adjustment mode is 10. Write the word mode here, is 10. That means that the object is at infinity and also the image is formed at infinity. And length of the telescope is 1.1 meter. Find the magnification when the image is formed at the least distance of distinct vision. We have seen that in case of a telescope, there are two lenses called as the objective, which had a bigger focal length, and the eyepiece, which had a smaller focal length. Light rays coming from infinity would fall on this lens, and then somewhere here, I'm just drawing the images, somewhere here we get an image called as AB. So distance from this to this point would be f naught, that's the focal length, and this image AB formed here acts like a virtual object for this eyepiece. Because of this, the image is formed somewhere here. So this is the image finally formed. We call this as A dash B dash. Distance from this to this point would be UE, because this acts like an object for the eyepiece, and this would be VE. Even here also, the length of the tube is given as f naught plus UE. So this is what is length of the tube. The magnification when the image is formed at infinity, it's called as m, that is given as minus of f naught by Fe. If you take only its magnitude, then because minus sign indicates that the image is inverted, if we only take the magnitude, then in terms of magnitude, m is equal to f naught by Fe. It's all been covered in theory lecture, you can go back and look at there. Now the question says the magnification is 10. This is given as 10. So 10 is equal to f naught by Fe. Therefore this implies that f naught is 10 times Fe. But here both are unknown to us. And what is given here is, it says length of the tube is given as 1.1. But this is when the image is formed at infinity. We learned in theory classes that whenever the image is formed at infinity, in this case for lens, it will mean that UE is equal to Fe, because a lens has two focus points, and if the object is kept at one focus, then the image is formed at infinity. This is what it means. So that would imply L is equal to from this equation f0 plus uv, which is f0 plus fe, and this L itself is given as 1.1. So from here 1.1 is equal to, we can write f0 as 10 times fe from this expression plus fe. That implies 1.1 is equal to 11 times fe, or fe is 1.1 by 11, that is equal to 0.1. It would be in meter because L is in meter, so fe is equal to 0.1 meter. From this expression, f0 is 10 times fe, that will be 1, so 1 meter. The objective would be having a focal length of 1 meter. So add f0 and fe would get 1.1 meter. So this is correct. Question says find the magnification when the image is formed at least distance of distant vision. We learned that the magnification for telescope when the image is formed at least distance of distant vision is given as minus of f0 by fe into 1 plus fe by d. This is what we get. It is equal to, this term is 10 because f0 by fe would be 10 from here. This is what is given earlier. So minus 10 into 1 plus fe is 0.1 meter, and d, we know the value of d, it's already given here, which is 25 centimeter. So if you write in terms of meter, that will be by 0.25, that's minus 10, 1 plus 0.1 by 0.25 will be equal to 0.4. So it's 1.4. So minus 10 into 1.4, that is minus 14. So the magnification is minus 14. Observe here that when the image is formed at infinity, it is 10, otherwise it is 14 here. So for this setup, for these two lenses of focal length 1 meter and 0.1 meter, the range of magnification is between 10 to 14. So m is between 10 to 14. The minus sign here just indicates that the final image, which is a dash b dash, this image is inverted with respect to the object. That's what minus sign means. Example 4 says an astronomical telescope produces a magnification of 25 in normal adjustment mode. The distance between the objective and eyepiece is 104 centimeter. Calculate the focal length of the lenses. So we know that the length of the tube, which is called as, which is given by capital L, this capital L is given as f0 plus fe when the image is formed at infinity. I just put symbol here, and this is equal to 104 centimeter. And also what is given here is, it says the magnification in normal adjustment mode. We saw in theory class that normal adjustment mode means that the object is at infinity and also the image is formed at infinity. So in terms of magnitude alone, this m is equal to f0 by fe, that is equal to 25. So from here f0 is equal to 25 into fe. We put it back here from this expression, we can say that 25 fe plus fe is 104 centimeter because f0 is 25 fe. Therefore 26 fe is 104, or fe is 104 by 26, it's equal to 4. But this L is in centimeter, so this also would be in centimeter. FE is 4 centimeter, and from here, from the expression of this form, we can say that F naught is 25 times FE, that is 25 into F would be 4, it's equal to 100 centimeter. So F naught is 100 centimeter. If you add F naught and FE, that is 100 plus 4, we get 104 centimeter. Example 5 says, the focal lengths of the objective and eyepiece of a compound microscope are 1 centimeter and 5 centimeter respectively. An object is placed at a distance of 1.1 centimeter from the objective. If the final image is formed at the least distance of distinct vision, what is the distance between the two lenses? As in earlier, we'll just read a diagram for it. If you have two lenses, we'll call this as the objective of a small focal length and the eyepiece of a bigger focal length. Suppose somewhere here an object is placed. Example thing, it's placed somewhere here. We'll call this as A, B. Its image is formed somewhere here. We'll call this as A dash, B dash. These diagrams and the derivation is already done in the theory class. You can go back and look at there if somebody has doubt on this topic. This image formed because of the objective. This is the objective. This is the eyepiece because the eye is somewhere here. So this image formed because of the objective acts like a virtual object for this one, and then the image is formed somewhere here. We call this as A double dash, B double dash. Distance from the optic center of objective to this point is called as U naught, and U naught is negative by sign convention. Distance from this objective or this optic center to this would be V naught because this is the image for the objective, and distance from this to this would be UE, and this would be VE. So here question says, what is the distance between the two lenses? That is called as length of the tube, capital L. So capital L is given as V naught plus UE. It's only the magnitudes. We'll first write data given in the question. The focal length of objective and eyepiece is given. Both are convex lenses, and so it will be positive. So focal length of objective is given as 1 centimeter, and for eyepiece it's given as 5 centimeter. An object is placed at a distance of 1.1 from the objective, so U naught is given as 1.1 centimeter. By sign convention it would be negative. So question says, if the final image is formed at the least distance of distinct vision, that is VE is equal to D, that will be minus 25 centimeter, because the sign convention, the light from the object is going like this, and we are going opposite to find what is VE. So here VE is negative. So we need to first find what is V naught and then UE to get the answer. We'll do it step by step. We'll first find what is UE. So by using length equation, we know that 1 by F is equal to 1 by V minus 1 by U. Since we're writing for the eyepiece, we'll put suffix e here. In this case, VE as well as UV is negative by sign convention. So this becomes 1 by FE is minus 1 by VE plus 1 by UE. So from here, this implies 1 by UE is equal to 1 by FE plus 1 by V naught. FE is 5 centimeter. It's 1 by 5 plus 1 by V naught is, this is V. This is V basically. So V would be 25. That is equal to 25 plus 5 by 25 into 5. That will be 30 by 5 into 25. That is 5 ones are 5, 6 times. This is 1 by UE. So UE is equal to 25 by 6. That is equal to 4.17 approximately. This is what is UE. We found out what is UE. So this term is done. Next, we should find what is V naught. Again, we use a lens equation. And do it here. So from here we can say 1 by F naught is 1 by V naught minus 1 by U naught. But keep in mind that by sign convention, V naught is positive because we are going from the optic center like this to find V naught. So V naught is positive, but U naught is negative as already given here. Therefore, what I get from here is 1 by 1 because it's 1 centimeter only. This is equal to 1 by V naught minus 1 by minus of 1.1. That is 1 is equal to 1 by V naught plus 1 by 1.1. Bring this side. So 1 by V naught is 1 minus 1 by 1.1. That will be 1.1 minus 1 by 1.1. So V naught is 1.1 by 0.1 because 1.1 minus 1 is 0.1. And this is equal to 11 centimeter. So we found out what is V naught, what is UE. Therefore, recall that L was given as V naught plus UE in terms of magnitude is equal to 11 plus 4.17. That will be 15.17 centimeter. So this is the required answer. Example 6 says a small telescope has an objective lens of focal length 144 centimeter and an eyepiece of focal length 6 centimeter. What is the magnifying power of telescope? And what is the separation between the objective and the eyepiece? Now recall that in case of a telescope, we can have two magnifications. One, when the image is formed at least distance of distinct vision, it's given as MD, that is equal to minus of F naught by FE 1 plus FE by D. And also we can have magnification when the image is formed at infinity. In that case, the magnification is given as minus of F naught by FE. Here, nothing is given about the image formation. So in such cases, by default, the condition is called as normal adjustment mode, where the object is at infinity and also the image is formed at infinity. So in case of telescope, if nothing is given, it would imply that the condition is normal adjustment mode and hence use this expression. Now here we should find what is M infinite. That's the first thing. Second thing is what is the separation between objective and eyepiece. We saw in theory classes that when the image is formed at infinity, then the length of the tube, which is the distance between the objective and eyepiece, that is given as f0 plus fe. So let's find them one by one. Here f0 is given as 144 centimeter and fe is given as 6 centimeter. So m infinity is minus of f0 by fe, that is minus of 144 by 6. Both are in centimeter, that is equal to minus 24. Again here minus sign implies or means that the image is inverted. Next thing is length of the tube, and that is given as f0 plus fe. f0 is 144 centimeter plus fe is 6 centimeter, is equal to 150 centimeter.